Hello to one and all. Today, I, Mishi Pallav of Group 263, will like to present a PowerPoint presentation on our IWS topic of hypothesis testing comparing two groups and ANOVA test. Let us share screen and then start the PPT. Let's start from the beginning. Slideshow. IWS topic is hypothesis testing comparing more than two groups and ANOVA test. My variant of PPT is number 4 and this is week 14 work. The index says that we will study what is hypothesis testing. Second topic is comparing more than two groups. Third is what is ANOVA test, also known as analysis of variance. Fourth is basic principle. Fifth is assumptions of uses in ANOVA test. Sixth is the following steps involved in ANOVA test. Seventh is ANOVA techniques. A is one-way ANOVA, also known as single factor, and B is two-way ANOVA. Subtypes of types of two-way ANOVA test, and second is a graphical method of interactions in two-way ANOVA design. Let's start. What is hypothesis testing? A statistical hypothesis is testable on the basis of observed data modeled as a realized values taken by a collection of random variables. Its purpose is hypothesis testing is used to assess the plausibility of a hypothesis by using a sample data. The test provides evidence concerning the plausibility of the hypothesis given in the data. Statistical analysts test the hypothesis by measuring and examining a random sample of population that has to be analyzed. The method of hypothesis testing is first we state null, also known as H0 hypothesis, and alternate hypothesis, denoted by H1 or HA. Second step is we select the distribution of use. Third is we determine whether we have to do rejection or non-rejection regions. And fourth, we calculate the value of test statistic. And fifth, we make the decision, and on the basis of that decision, we draw our conclusions. Now, what does the result of a hypothesis testing is? In which some researchers say that the hypothesis test can have one of the two outcomes. First is that you accept the null hypothesis, and second is you reject the null hypothesis and accept the alternate hypothesis. Failure to reject implies that the data is not sufficiently persuasive for us to prefer the alternate hypothesis over the null hypothesis. For example, an engineer measured the hardness of 25 iron pieces to test the ductile iron that has to be annealed. The resulting data of the engineer hypothesized that the mean value would be brinell hardening of all the ductile iron pieces should be greater than 170. Therefore, his null hypothesis is that mu represented by mean should be greater than 170 and H0 mu is less than 170. HA alternate hypothesis is generally opposite of the null hypothesis. Now let us talk about some errors. In this hypothesis testing during conclusion, there are two types of errors, type 1 error and type 2. If we do not accept the correct conclusion, For example, we have the correct conclusion is that we have to accept the null hypothesis. But based on our calculations, that are correct calculations, but the calculations support that we should reject the null hypothesis knowingly that it is correct. This is type 1 error, in which the true state of nature is that null hypothesis is true, but we consider null hypothesis is false. Then type 2 error is that we accept false hypothesis. That here null hypothesis should not be considered, but we prefer null hypothesis based on our mathematics calculation knowingly that it is false. And here true nature of the state is that null hypothesis is false, but uh, we still say that null hypothesis is true, and this is type 2 error. Let us move forward now. Second is comparing more than two groups. In this, analysis of variance, also called ANOVA test, is a method for testing the hypothesis that there is no difference between two or more population means. The ANOVA technique enables us to perform simultaneous tests as such as considered to be an important tool for analysis in the hands of a researcher. A signification of the difference of means of the two samples can be judged through either z-test or t-test. These two tests are another test other than the ANOVA testing that are also used for comparing groups. But z-test is applied to find out degree of reliability of a statistic in case of a large sample, and z-test is based on the normal probability distribution and is used for judging the significance of several statistical measures. Particularly, it does its all measurements around the mean value. In t-test, the test of null hypothesis uses population means of the two groups are same in t-test with two samples. Commonly it is used in cases of small sample size and testing the difference between the samples when the variance of the two normal distributions is not known. T-test is also used for judging the significance of the coefficients of simple and partial correlations between the sample of the population. T-test is also used when more than two means it is possible to compare each mean with each other using t-test. T-test can be used for comparing more than two groups. But the problem here is when, however, conducting multiple t-tests can lead to severe inflation and type 1 error rate. It can increase, and there are more chances of type 1 error in the hypothesis testing if we go for comparing more than two groups using t-test method. And to avoid this error, we use ANOVA test. ANOVA is used to test the differences among several mean of significance without increasing type 1 rate. And that's why it is used in the statistics for comparing more than two groups. And I will recap that type 1 error is in statistics rejection of true null hypothesis that we saw in the previous slide. Now, my third slide is what is ANOVA test or analysis of variance. ANOVA is a procedure for testing the difference of data for homogeneity among different groups. About the essence of ANOVA is the total amount of variation in a set data is broken down into two types: the amount in which it can be attributed to chance, and the amount which it can be attributed to specified causes. Here you can see in the picture ANOVA test in Excel we can perform by making tables using mathematical operations and finding the result by comparing the statistical and critical values, and then making a appropriate decision, and on the basis of that we can find the conclusion. Or we can go for the data analysis tool, in which we can use ANOVA single factor for one way, or two factor for two-way ANOVA with replication or without replication. The ANOVA technique is important in context of all situations where we want to compare more than two groups of populations. In such circumstances, we do not want to consider all possible combinations of two populations as at the time, for that would require a great number of tests before we would be able to arrive to a decision. So ANOVA technique is used to compare different groups of data simultaneously without any error. Fourth is the principle. ANOVA test has a principle that the test is based on differences among populations by examining the amount of variation within the samples and a relative amount of variation between the samples. So the crux is that its principle is it is based on samples variation within the sample and between the samples. Assumptions are that each group sample should be normally distributed population. It means X mean should be equals to X median, and in some cases X mean, X median and mode, all three should be equal. Then we would say that on the basis of central tendencies it is normally distributed, or we can use the histogram bell shaped, and also we can use the Gaussian laws 3 sigma rule. These are the ways to test the normality of a sample. Second is all population have a common variance. Third is the all samples drawn independently of each other, and they are unrelated. With each sample, observations of the samples are randomly and independent of each other, and the factors' effects are additive. The presence of the outliners can cause problem because in addition we need to make sure that the F statistic is well behaved. In particular, F statistic is relatively violations for the normality provided. The populations are symmetric and unimodal. The sample sizes of the groups are equal and greater than 10. In general, as long as the sample sizes are equal, we are called as a balanced model or a uniform model, and is sufficiently large, the normality assumption can be violated provided the samples are symmetrical or at least similar in shape, uh, for example, negatively skewed. The F statistic is not so robust to violations of homogeneity in variances. The rule of thumb for balanced models is that the ratio of the largest variance to smallest variance is less than 3 or 4. The F test will be valid. If the sample sizes are unequal, then smaller differences in the variances can invalidate the F test. F test is also known as Fisher test. Much more attention needs to be paid to unequal variances than to non-normality of the data. Now, let us study the steps involved in ANOVA test. How do we perform a method by hand if we have to make a ANOVA test? First step is that we obtain the mean of each sample. Second is we find the mean of the sample means. And here is the formula: x1, x2, x3, k. They are mean of the different samples. We collect them, add them, summate them on the upon number of samples, that are k. Then we calculate the sum of square of variances between the sample, and this is ss between. Here we can see, and then we calculate the mean of mean square between, ms between, this is ss between k, which is number of sample minus 1. Then we calculate the sum of squares of variances within the sample, that is ss within. Here is the formula. Then the sixth step is that we calculate the mean square within, ms within, ss within upon n minus k. Then we calculate the SS of total variance, and then SS of total variance is nothing but the sum of SS between and SS within. The degree of freedom between and within must add up to the degree of freedom of the total variance. N minus 1 is equal to k minus 1 plus n minus k. Here n is number of groups, number of individual groups. Then the F ratio is ms between upon ms within. The ratio is used. Why F ratio is important? Because it helps us to judge whether the difference among several sample means is significant or is just a matter of sample fluctuations. Seventh is ANOVA testing. As I mentioned in the index, there are two types of ways, two types technique. One way ANOVA test, also known as single factor. T test, how we use T test, it is a simple type of ANOVA only, in which only one source of variation or factor is investigated. It is an extension of three or more samples to the t-test procedure for use with two independent samples. In another way, t-test for use with two independent samples in a special case of one-way analysis of variance. Like we use t-test, similar ways we can similarly we follow the steps of one-way ANOVA. In one way ANOVA, the measurement of glycogen content of multiple samples like heart, liver, lungs, kidney is one example in which the factor is the glycogen content, measure of glycogen content, and different groups are heart, liver, kidney, lung. And here there is one factor, glycogen content, on which we are comparing different levels or groups, individual groups. This is an example of one way ANOVA. Then two-way ANOVA technique is used when the data is classified on the basis of two factor. For example, agriculture output can be classified on the basis of different varieties of seed, and also on the basis of different varieties of fertilizers used. Here, different varieties and fertilizers are two factors. A statistical test of two nominal predictable variables on a continuous outcome variable is used to determine the effect of two-way ANOVA test and analyze the effect of the independent variables on the expected outcome along with their relationship. Two-way ANOVA design may have repeated measurements of each factor or may not have repeated values. Here we subdivide the two-way ANOVA technique on the basis of whether the values are repeated or not. There are two ANOVA technique in context with repeated values are there present and in which repeated values are not present. These two are done. These calculated on the residual or error variation by subtraction. Once we have calculated the sum of squares of total variance and the variance between the varieties of each treatment, as also the variance between varieties of other treatments. ANOVA technique in context of two-way design is graded values. We obtain a separate independent measure of the inherent or the smallest variations. Interaction is the measure of the interrelationship among the two different classifications. It means that the two-way ANOVA test with replication and without replication. With replication, the sample size is different, not uniform, not balanced. And in case of without replication, the sample size is uniform, well calculated, and a balanced data. Here I will show with repeated measures and without replicated and with replicated. In with replication, we analyze on the difficult is difficult because the two groups and the individuals within the group are doing more than one thing, taking two tasks or two tests. But without the replication, sample is more uniform. Means are calculated independently and hence making the data balanced data. Results are faster. But here is a problem of nuisance factors that affect the measurement of the result. Like, for example, we are applying a treatment and nuisance factors might be they are not our primary concern, but they can affect our results. Like, what is the specific operation, who prepared the treatment, time of day, experiment and room temperature, all the equipments present in it. These are all factors that can put their effect on the treatment. So we have to control the nuisance factor by a technique called as blocking. Now here in this chart we can see ANOVA with versus without repeated measures. Here we can see that in without repeated measures, we can compare three groups. Uh, Here we can take 10 groups, n is 30, means sample size greater can be measured over here. But in repeated measures, only 10 pairs are taken, but the sample size is just 10. It means that here it is um, without replication, it is more uniform, but with replicated measures, it becomes cumbersome. Here we can see that the mean of the population is equal. But the null hypothesis is when mean is related. When population means are related, then only we can state the null hypothesis. This is one point. Then differentiability, all variability in without replication is not explained by um, the condition of single error or residual terms, sum of squares condition. But here in the variability is not explained by the condition. It explained by determining how the individual subjects respond. This reduces the amount of unexplained variability error. So here we can see that repeated measures have a slight advantage when sum of squares condition between the groups is seen. And here the residual error can be measured or can be explained properly. Um, Now the graphical representation. Graphical method of studying interaction in two-way design is for graphs we select each of the factors to be used on the x-axis line. Here is an example in which graph of averages of the amount of blood pressure reduction in millimeters of mercury for different drugs and different groups of people. So here we can see there are two factors, and this is a two-way ANOVA test. Here on the x-axis we took the number of drugs, and on y-axis we took blood pressure reduction in millimeter mercury. Here we have selected the one of the factors to be used on the x-axis, and then we plot the averages of all the samples, that is the measurable blood pressure reduction in millimeter mercury on the y-axis for each variety of on a distant line. If the connecting lines do not cross over each other, then the graph indicates that there is no interaction, no linking. But if the lines do cross, they indicate a definite interaction or interrelation between the two factors. And as we can see, A, B, C are different groups, and they all three interlink or intercross one another. Here the graph indicates that there is a significant interaction because different connecting lines of groups of people do cross over each other. We find that A and B are affected very simultaneously, but C is affected a little differently. Here we see that A, B are more affected and more interlinked to each other. Before going on references, I will like to recap one-way ANOVA and two-way ANOVA. In one-way ANOVA, we identify the difference between the means of three independent, unrelated groups on one factor. Independent factor is one for numerical and measurement variable. Means of three or more groups are on the dependent variable. Here, in one-way ANOVA, number of observations should not be same in each treatment of group, but here still we can use one-way ANOVA. But in two-way ANOVA, the sample size should be same. Two-way ANOVA is a special case of the factorial ANOVA with two factors. Independent factors are two. Factor A with two or more levels crossed with factor B having two or more levels. Effect of multiple groups of two on a dependent variable on each other simultaneously. Here it is necessary that the sample size need to be equal in each treatment of groups. That only we can compare the both groups correctly. For example, we might measure a response of three different drugs in both men and women. So here drug treatment is one factor and gender is another factor. So two factor. So two-way ANOVA test. One factor, one-way ANOVA. This was my recap. Now I will like to explain the references that authors and books associated. ANOVA by example, hands-on approaching ANOVA is one book, then statistics introduction is another, then these three are web links. So this was my PPT. Thank you for your attention, and I have also made my abstract, my report. which is the content is most likely to be same, but I will just show for assurance. This is um, my report. Here is my content. Here I have introduction, main part, conclusion, and references. Everything is same, what is ANOVA and all. Only conclusion is something new that I have added and explained in detail, that what we all learn from this, and then reference is in the alphabetical order, and all the information is given in the report. Thank you and have a nice day. टाइम से बाहर चली गई। कहाँ पर है?